Right, so we're going to configure this network. So in this case we'll use the Vyatta firewall. It's got 3 network connections. The first one connects to the public network, the second one to the private, and then the third one to the DMZ or the demilitarized zone. In the public network we'll use DHCP, so the IP addresses are granted from this gateway here. So there's no need to set these IP addresses up. In the private network, we will set up a 10.10.something.0 network. You'll be allocated the value of X and the value of Y for your network. In my case, I'll set up 10.10.10.0 and 10.10.11.0. Then we'll put the host on at .7 on each network. So the Ubuntu machine is on at 10.10.10.7 in my case, and 10.10.11.7 in this case over here. We also need the default gateway, and that's important because the host needs to know the default gateway to be able to get out and onto the internet or onto other networks. So in this case it will be 10.10.10.254 and 10.10.11.254. Okay, so we'll go ahead and we'll get this set up. So I'll just log in. Okay, so you may find that you start off in this tab here, just click here, production, find your module number, and then you should be able to find your virtual machines. So in this case I've got 2 Kali machines on the DMZ in the public, a pfSense which isn't used in this lab, so make sure that that's switched off. I have my Ubuntu machine in the private, my Vyatta firewall, and the Windows 7 machine on the DMZ. Okay, so what I'm going to do is initially I'm going to just power on each of these machines. So I'll power on the public Kali. We'll just use that one to test that we have internet connectivity, nothing else. I'll power on the Ubuntu machine. If you're ever stuck, go to snapshots and revert the snapshot back from here. That'll take it back to a clean instance. But in this case it is clean just now, so I'll just power it up, and I'll power up my Windows 7 machine and we should be good to go. So the first thing I'll do is I'll just give our network a little test just to see if we've got internet connectivity, and I'll log in. Okay, we'll have a look, see what we've got, and we use IP address show, and we can see the IP address is here. It's been granted through DHCP, so everything looks fine there. We can also use ifconfig, I think that's installed, and there's the address there and the subnet mask. Okay, so you should find that you can ping your own address. So that's 10.221.1.81. That's fine. We should be able to ping the default gateway, which is the last address on that subnet, which is fine. And now we'll see if we have internet connectivity. If we don't have internet connectivity, then we'll struggle to get the rest of the network set up. That works fine. And now we'll test to see if we've got our DNS working on domain name service, which will resolve the domain name to the IP. That works fine. That's the basic steps we typically go through when we're debugging. Ping yourself, ping the default gateway, ping 8.8.8.8, ping Google, see where it's not actually working. You can also use NSLOOKUP to see if our DNS is working, and you can see in this case it is working. Okay, so that's fine, everything's working there. If we want, we can suspend our virtual machine, and if we're not using it, then it's as well that it's actually suspended. Just let me check. I'll just suspend it now. Okay, so it was already suspending, so everything's fine. So the first thing I'll do is I'll set up our Ubuntu machine. Just dismiss that one. Okay, just let me refresh here. think should be popping up. There it is there. Okay. Okay, so this is the Ubuntu machine on the private network. So we can have a look to see its address. And the one thing you should see is the name of the address, ENS32, but it's also down. So we'll make sure that we put it up, and we'll just add in our IP link, set ENS32 up. That should enable our interface. Okay, if we go back again, hopefully we should see the interface is up. So we'll set our IP address, add 10.10.10.7/24, it's a 24 network, and dev ENS32. That's good. So we should be able to ping that interface and it should be alive. Good. Now we've set up the default gateway. So we need to IP route, add default via 10.10.10.254. Doesn't exist yet, but hopefully it will be set up in a little minute. Okay, if we ping that, then it won't exist because we've not set it up yet. That's what we would expect. Last thing I need to do is to set up the DNS. So that's held in the etc.resolve.com file, and we'll set up that to be the DNS for our setup, which is that 10.221.3.254. Save that, and everything should be set up. Okay, so we can now leave the Ubuntu machine and we'll go to Windows 7. Okay, so we'll get this one set up. Okay, so network, right click, properties, adapter settings, right click on the Ethernet adapter, and IPv4. Okay, if we remember that we're on 10, well, I'm on 10.10.11.7, 255.255.255.0, and the default gateway is 10.10.11, in my case 254. The DNS comes from the main gateway that I showed you, and it's at 3.254 there, so everything should be fine, but it won't connect to the internet at all. Because the firewall isn't there yet. So if we ping ourselves, hopefully that will be alive, but when we ping the default gateway or Google or anything, then it won't work, as we would expect, because there's no firewall there. Okay, so we'll just park that one there, and now we'll go to the firewall. Okay, so I'll just recap where we are. So I've configured the IP address here. I've defined the default gateway, and I've also defined the DNS for the Ubuntu. Same again for Windows. I defined the IP address, the default gateway, and the DNS, and that's really all those devices require. Okay, so now let's go and configure our Vyatta. Okay, so now let's log in. Okay, so we've got two modes. This is the normal administrative mode, and we'll go into an edit mode to be able to change the configuration. We can use the show command here. There are some of the options. We can view the hardware history, the ARP table, and so on. The history. And what we want to do is to show the configuration. So the configuration is organized into things like interfaces, system, routing, and so on. We can see we've got 3 interfaces here. It has their MAC addresses, but very little else. We can also view the interfaces to see if they're up or down, or if they have any IP addresses. So let's go ahead and we'll set up some of the configuration. So we say set and then system. We can put the question mark to see the options, but we'll set up the host name and we'll set it up as Bob. Then we'll set up the login here for the user, and we'll make that Bob. And authentication is a plain text password, and we'll make it password. Okay, what we must do is we must commit that, and then we will then exit from here. We can exit from there too. So now I can log in with Bob. Okay, so that's me. So next thing we'll do is we'll set up the IP addresses to make sure that we can get the routing to work. So for this, it's set interfaces, Ethernet, and ETH0 is on DHCP. We can recall the command with the up arrow and scroll along. And ETH1 is 10.10.10.254. So I'll put an error here just so that I can show you how we update it. Okay, so if that's an error, then what I do is I can actually delete that one. Okay, so that actually deletes the command that I've applied. So I'll go back in and I'll just modify it with the right address, 10.10.10.254, and that's fine. So ETH2 is 11. We'll just have a look at our interfaces just to see if they're all set up okay, and that looks fine. Yep, that's okay. And the last thing we'll do is we'll set up the default route. So the default route is when a packet comes in and the router doesn't know where to send it to because it hasn't learned that network, say it's for the internet, then the firewall will send it to the default gateway, and hopefully the default gateway will know how to route it. So we set up a static route for that, and it's to pick everything. It learns the networks it connects to. So this is for the default where it doesn't know how to route. And the next route will be 3.254. Okay, so we'll just have a look at our configuration again. And we'll just try and ping one of the interfaces, and we'll see that the network is unreachable. And the reason for that is that we should have put show interfaces there. That shows that one. We can't do the show configuration in this mode. We can only show one of the options within the configuration. So we see that we can't ping our network interface, and the reason for that is that we haven't committed yet. So we'll commit that, and then we can exit from here. So if we now ping the interface, then hopefully it's the wrong one, 254. Yep. Okay, so that's working fine. Okay, so we'll have a look at our configuration. this time. We'll get it. And we'll just check 10.10.10.11.254, 10.10.10.10.5. That's fine. Okay, so everything looks to be working there. We have our default gateway working. So let's see if we can ping, and we can. So that's working. So it looks like we've got internet connectivity from our firewall. Now we need to make sure that it's all working on our hosts. So let's go back to our Ubuntu machine and see if it can see the firewall, and it can. Okay, so now it sees the port that we've set up, and fingers crossed. Okay, so we can ping our host. We can ping the default gateway, so that's now working, but we can't get internet connectivity. And the reason for that is that we need to set up our Nat routing. So let's go ahead and continue with the lab. Okay, so the main thing here is that we have our connectivity to our gateways. So we'll try our Windows machine, and we've got connectivity, but we still don't have internet connectivity. For that, we need to set up our NATing, or network address translation. Okay, first I'll show you about setting up the interfaces. So if we want to delete any of our commands, let's say that we have our interfaces. So we can go back into configuration and we can delete an interface. So we can recall the command that we used to implement that. So let's say we delete eth1 and commit. And now when we try to ping that interface, then you'll see that it doesn't ping. If we go to our Ubuntu machine and we try to ping, then we can see the interface doesn't exist anymore. We go back to our Vyatta and we'll reinstate the interface. And again we commit, and we'll try and ping it, and it exists. Same over here. If we now try to ping it, then it exists. Okay, so what we should have now is that the two networks will have been discovered. So the Vyatta firewall will know how to route from the Ubuntu network into the DMZ. So let's try and ping the host on the other network, which is the Windows machine, and that works perfectly. So now we'll open up the Windows machine and we'll try to ping 10 the Ubuntu machine, and that works perfectly. What we should find is that there is a web server running on the other host. So if we try 10.10.7 to run nmap will discover the services that are running on the Ubuntu machine. Just takes a little minute, and we'll do the same over here. Nmap 10.10.11.7. And we can see one of the services that are running on the Ubuntu machine is HTTP. So let's actually open that up. 10.11 http 10.10.10.7, and we can see from the Windows machine this is us accessing the web server on Ubuntu. We can do the same again because we should see that port 80 HTTP is open on the Windows machine. So what we can do is that we can open up the web server on 10.10.11.7. There is the Windows IIS web server ready to be connected to. Okay, so that shows us that we can connect to our services, but we still can't get connected to the internet. If we try to Google here, then it's not going to work because there is no connectivity between our networks and the external network. For that, we need to implement or configure network address translation. Okay. So we'll bring up our Vyatta firewall again. And now we'll go and configure it for Nat. Okay, outbound. So the outbound interface is the public interface, which is ETH0. So we'll also set up rule source address set Nat source rule 1 source address 10.0.10.0/24. So this is going to map our private network to the external network. So it overloads the IP addresses and maps them onto a public network address. So set Nat source rule 1 translation address and masquerade. Okay, so this is where the IP address overloading happens. We take private IP addresses and we map it onto a public IP address. Next we'll do the same, but this time we'll do it for the other network. So we want source address is 11. That's fine, and then we'll do rule 2 masquerade. Okay, so that's that set up. Now we should be able to commit that. Everything's good, and we'll exit and we'll show our configuration just to check that it's all been set up. Okay, so there's the rule outbound interface is the public network. We're mapping with the first rule our private network, and then for the second rule we're mapping the other network. Okay, so fingers crossed, let's see if this is going to work. Okay, so we go back here and we do ping 8.8.8 and it works. So our network address translation has worked. Now let's see if we can ping google.com, and that works too. So we can see here that we now have internet connectivity. Everything's looking good and we should be able to get access to Google, which is great. It's good news. And that's worked, and it was because we set up our network address translation to be able to do that. Now we'll go to the Windows machine and we'll just check that that's going to work. Ping 8.8.8.8, And it works, yes. And we'll see if our DNS is working. It's working. We can use NSLOOKUP if we want. That's working fine. And then hopefully we will get Google to come up here. And it does. That works perfectly. Okay, so you can now see that because we set up the NAT on the firewall, that it's all working now. We've got our connectivity and all our services are working, but it's not working as a firewall quite yet. It's basically just routing. Let's see if we can now do some more configuration. Okay, so one of the services that we often run is an SSH service. Obviously we need to go into configuration mode first, set service SSH, and we'll commit to that. Okay, so that's fine. Now we'll go back to our Ubuntu machine and we'll run SSH. So 10.10.10.254 and our username is Bob. Okay, we'll say yes to that. And Bob's password was password. Okay, so we're now in the actual firewall. This is as logged in. You can have a look. Show configuration as we did before. We can see that. Okay, so although it looks like we're in Ubuntu, we're actually in the firewall just now using SSH. If we want, we can start up another terminal and we can run Wireshark. I'll put an ampersand after it so it runs it in the background. Just takes a little minute to start up. Password. Okay, so we'll capture from our network adapter and we'll just do some basic commands just to see what we get for our Wireshark. Okay, so here is an example here. What we'll do is we'll start it back again. So we'll just log out here of our SSH and we'll start our capture. But then I'll just ping just to see if we can capture some ping packets. Okay, and I'll ping an address that doesn't exist and we'll see what it gives us. Okay, so here is the traffic here, and what we should see is that the ICMP is the ping that we're sending out to there. We'll be able to, later on in the module, be able to see some of the details there. If you want to just look at your IP address, then you will just type in here for .7 and it should just show you the packets just in case you're getting packets from others. There's the request and there's the reply there. We also see what's called ARP, and ARP is a discovery protocol that we can use to be able to discover other networks. If we have a look at ARP, -A, then we can see these are the two addresses that we've discovered on our own network. So there's the default gateway, and that's that address there, and obviously this one didn't complete. Okay, so we find hosts on our own network and we put the MAC addresses into the ARP cache. Okay, so up to this point we've got our connectivity working. Now what we'll do is that we'll set up our firewall. I'll configure the commands from the terminal here, but often what we would do is we would connect in with SSH and copy and paste the commands in. But in this case, I'll just set them up by manually typing the commands in. Okay, so what we do is we set up a zone policy, and I'm going to set up a policy that will allow traffic from the private to the DMZ only for port 80 and 443, but allow all traffic from the DMZ into the private network. I know it sounds a bit strange, but that's just what we'll do, just to make sure that we can show it working. Okay, so I'm going to give it the name private for my zone policy, and we'll give it a little comment of inside. And I'm going to give the name of my public policy. Give the name of public, and that's outside. And I'll give it the name of the DMZ. That's called the DMZ. Now what I'll do is apply those policies onto the interfaces. So I'll set the zone policy. Zone knows the name public, so that's fine. That gets applied onto interface ETH0. Now I'll apply the private interface onto ETH1. And finally I'll apply the DMZ onto ETH2. Okay, that's fine. So what we'll do now is that we'll commit. Well, we won't commit yet. So we'll just check to see that all our services are working. So if we nmap onto 10.10.11.7, and then over here nmap 10.10.10.7, we can see all the ports that are running on the other host, so there's no firewalling. And again over here there's no firewalling. We can see all the Windows services that are running. Okay, so our firewall hasn't really been applied yet. So that's it. Okay, so now what we'll do is that we'll apply our firewall rules, and DMZ to private, description DMZ to private, set firewall name, it's got that name already, and our first rule is to accept. We'll modify that rule. Set firewall name DMZ to private, rule 1, state established enable. This means that anything that's been established as a connection will be allowed back again, so the traffic will be allowed only if it's been accepted. So set firewall name DMZ to private rule 1 and state related enable. So this will accept all of the traffic from the DMZ to the private network. Now we'll allow only port 80 and port 443 to flow from the private network to the DMZ. So we'll give this a name of private to DMZ, give a description of private to DMZ, it's just a comment. Set firewall name, private to DMZ, rule 1, action accept, rule 1, state, action accept, state, established, enabled. So that will allow any connection that's been enabled already to flow back again from the private to the to DMZ. And state limited enabled. So that allows all the traffic that has been accepted through the firewall to return back again. So now we'll set the limits for the firewall, action accept, and for our destination ports of 80 and 443. Protocol is TCP. Okay, so that's our rule setup. So we will only allow from private to DMZ 18443, but we'll allow all the ports going the other way. So set zone policy, zone private from the DMZ, and we'll apply DMZ to the private. Set the zone policy, zone DMZ from private, firewall name private to DMZ. Okay, so we'll try and commit that. Fingers crossed. That's fine. Okay, so now let's see what's happened. So we'll go to our Ubuntu, and this one should be the one that's blocking every port apart from port 80 and 443. So let's see what we get now. We'll have a look over here, do the same over here, and there you go. So we can see here what's happened is that now the firewall is blocking traffic on all of the ports, all of these ones, and only allowing HTTP and HTTPS to flow. But over here, when we run Nmap, we can still see all of the ports. So if I now try to Telnet into or use one of the services here, then it won't work. Only port 80. So hopefully we'll still be able to access the web browser on the Windows machine. that works fine. But if I try to access any of the other services, such as FTP, then it won't work. Okay, so that shows you how the firewall is actually working. Okay, so we can actually do a test using Telnet by putting the port number at the end of it. So we can see here it logs in to port 80 and we can type in get/ and it gives us a response back. So that port is open. But if we now try another port, such as port 25, which was open, then that doesn't work there.